Hello friends, welcome to my channel, and now we are going to discuss about the next question. How does a battery work? Explain. Battery consists of two metal plates called electrodes and a chemical substance electrolyte. So we know a battery will contain two plates. These plates are called electrodes and there is an electrolyte. So a solution between these two metals. You can see here. So these are electrodes and this will be electrolyte. The accumulation of different charges on respective plates continues till both plates are sufficiently charged. So from this electrolyte, the ions get distributed onto the either plate. All the cations onto one plate and all the anions onto the another plate. This process is called accumulation. The amount of charge accumulated on the plates depends on the nature of the chemical used. So depending on this electrolyte, the amount of accumulation depends. When a conducting wire is connected to the terminals of the battery, then a potential difference is created between the ends of the conductor. So when there is a wire connected across the terminals of the battery, then there will be a potential difference created. This potential difference sets up electric field throughout the conductor, and this potential difference will set up the electric field around the conductor. The electrons near the positive terminal of the battery are attracted by it and start to move towards the positive terminal. So the electron near the positive terminal will be attracted. So which are moving in the conductor, the electrons in the conductor will be attracted towards the positive plate because of the force of attraction between the two oppositely charged ions. As a result, the amount of positive charge on the plate decreases. So as the electron enters here, they become neutral and the number of positive charge will decrease on this positive plate. So the electric force becomes weaker than the chemical force. The chemical force pulls negative ions from the positive plate and makes them to move towards the negative plate. Then the chemical force will make this electron to move towards the negative plate. The negative terminal pushes one electron into the conductor because of the stronger repulsion between the negative terminal and negative ion. Then this electron will be thrown out of the battery because of the repulsion between this negatively charged plate and negatively charged ion. Hence, the total number of electrons in the conductor remains constant during the current flow. So, the above said process continues till equilibrium is attained between the forces Fe and Fc, that is chemical force and electric force. Next, how do we verify that resistance of a conductor is proportional to length of the conductor for a constant cross-sectional area and temperature? Or what is the relation between the length of the conductor and resistance, and write the experimental procedure to verify the relation. So now we are going to prove that the relation between the resistance and length of the conductor. For this, correct iron spokes of different lengths with same cross-sectional area and like copper, aluminum, etc. So we are conducting activity to give relation between resistance and length. So we are making the length to change and we are keeping cross-sectional area and temperature constant, and correct the circuit as shown in the figure. connect one of the iron spokes at 10 centimeter length. So initially we are taking the length of 10 centimeter and connecting between P and Q and switch on the circuit. Measure the value of current using the ammeter connected in the circuit and note down the values. So now repeat this procedure for other lengths of iron spokes. So first we have tried 10 centimeter length. So next go for 20 centimeter, 30 centimeter, and repeat the experiment and note down the current values. So note down the corresponding values of current for different values of lengths. We notice that current decreases with the increase in length of the spoke. So as the length increases, the current decreases. They are inversely proportional. Here current decreases as the length increases. Thus the resistance of the each spoke increases with length for a constant potential difference. So we can say the resistance increases as the current decreases, current resistance increases. So here from this we can say the resistance and the length of the conductor is directly proportional. So we can conclude that the resistance of a conductor is directly proportional to its length for a constant potential difference. So R is directly proportional to L. And coming to the next activity, state Ohm's law and suggest an experiment to verify it and explain the procedure. How do you prove experimentally the ratio between V by I is a constant for a given conductor? So we know according to Ohm's law, the potential difference between the ends of the conductor in a circuit is directly proportional to the flow of current in the circuit. So as we increase the potential difference, the current also increases. That is what stated by the Ohm's law. So in order to remove the proportionality, I will multiply with a constant, and that constant is the resistance. So from this I can write V by I is equal to R. So the ratio between V by I is a constant. That is what we are going to prove in this activity. So we are connecting the circuit having a battery, an ammeter in series to the battery, a switch, and a voltmeter is connected across the conductor. So this is a conductor. Across a conductor, a voltmeter is connected. Now let's see the experiment. Set up a circuit as shown in the figure. The figure consists of a nichrome wire of length AB, say 0.5 meter, an ammeter, voltmeter, and 4 cells of 1.5 volt each. First use only one cell as the source in the circuit. So first use only we are taking a nichrome wire of length 0.5 meters, battery, ammeter, plug key, and voltmeter. So here first we are using only one cell, so 1.5 volt I am connecting here, and note down the reading in ammeter for the current and reading of voltmeter for the potential difference across the nichrome wire AB in the circuit. So for the current and potential difference across this nichrome wire, first observe the ammeter and voltmeter readings. Now tabulate the values in the table as mentioned below. So as the given in the following table, note down the readings of current in the ammeter and potential difference in the voltmeter when you connected one cell. Next, connect the two cells in the circuit and note down respective readings of the ammeter and voltmeter. Repeat the above steps using 3 cells, 4 cells, and so on, and calculate V by I ratio. So next connect 2 cells, next connect 3 cells and 4 cells in the circuit and note down the corresponding values of current and voltage. And for every set of current and voltage, take its ratio of V and I. And you can observe that the ratio between this V and I is constant, which we call as the resistance of the nichrome wire. So this value will be a constant. So when you plot the graph between V and I, you can see that the graph is a straight line from the origin. From the above activity, we will find that approximately the same value of V by I is obtained in each case, and the VI graph is a straight line that passes through the origin. So this is the graph for ohmic conductors. So what are ohmic conductors? The conductors which follow Ohm's law are called ohmic conductors. So from the above graph, V by I is a constant ratio, hence Ohm's law is verified.